I check out the group quiz and yeah, it's like we just like this is a bit
Check it. Check it. Can you look? Look.
okay. Over there. Get the danger.
Come play.
Get it.
No, it's okay. Yeah. I'll just keep an eye on them.
Alright. Sounds good. So, how do we see this is a PDF? Like, scan it or something, or what?
Yeah. I can do that though if you want. You guys, when we're done, I can take it and scan it if you want. And when you submit it for our group, you just put our names.
Let me double check that because I don't know if we all just got our own group quiz.
It's just the group leader. So like when you submitted the video, you like put our names in the video. So
stuff.
I think that would work. So the broadcast start?
Yeah.
It's on. Cool. So we are recording. So I don't know how much actually watches these things.
Me? Oh yeah, no, I don't know.
I don't know.
So teacher, if you're watching this, let me know. See it.
We're supposed to start with a prayer.
Probably.
I guess.
Yeah. Organized manner. Oh, goody. Neat or unorganized manner. I'm not the scribe. Well, submit one copy to the group. You only use your textbook and notes, calculator these problems. Source including internet, tutors, or solution manuals. So, I'm going to Julia is the scribe. Right? Hey, you. You're going.
So yeah, I can be a scribe.
So, everybody understands how to identify this transformation. Carol's transformation, which is that little graph, pretty helpful.
Yeah.
The function transformation.
Write the piecewise function for the figure below. You should identify the domain that corresponds with each equation.
So we're going to go have the quiz.
Yes,
Yeah.
like the piecewise function. For the figure below, you should identify the domain that corresponds with each equation. So it's actually pretty easy to see. Just look at the graph and just say, okay, well, goes from infinity to like this point, and this point to that point, and then that point to that point, but not including these points. Well, actually, it includes because it's closed. It's closed point.
Yeah.
Or is it the other way around? An open point.
So it's open. The domain is open negative infinity to close bracket 1. And it's like the U symbol, isn't it? Close bracket.
1, 2.
That'd be close bracket 0, right? Not X. First one X. Or
Well, so you go to infinity, and then right before it changes direction, or
okay, I see.
I mean, unless it changes directions, I like the point negative 0, when it goes to 0, 1.
I don't think so.
And then you go from 0, 1 to 1 point, 1 negative 0 to 3, 2.
So you're saying negative infinity is an open to 1, U, and then closed 0, 1, and close 1, 3.
So then you're infinity. To 0. Touch it. Look at this.
Oh, to 0.
One to negative 2. Or how does that work? Should be 0 to negative 2.
I looked at like the X.
Okay.
So
Confusion.
range one of the X or Y, and the domain is the
Domain
X.
is the X's.
Domain of the X's.
0, And we got 0, 1, 1.
So, if we look at like the x-axis, like do like I guess like the vertical test and like goes all the way until like so when the domain is negative, infinity is 6, and the domain would be like negative
Yeah.
or range of negative infinity to
2.
yeah.
It's true.
Don't you know? Can I see you? Shit.
How do we write the piecewise function? F of x equals piecewise like absolute.
I thought piecewise was just like piecing together the parent functions. Are we so we're supposed to write a function for this graph?
Mm-hmm. Right.
Yeah.
Write the piecewise function for the cube below, and then identify the domain corresponding to each equation. So each equation
It would be each line, so like negative infinity to the first point, and then the second point to this. The second point to this, or the third point to the second point, and then the second point to the third point, and the third point to the last. So they're all like different functions. And then we need to find the domain for each function. But generally, the domain is for negative infinity.
So the first one is hello? I'm still at my group meeting. Like Tim. Who are these two?
10.
Oh, they're easy.
No,
But
not right now. When you get older.
so the first one would be
Yeah, when you get older.
x plus 1. No, wait.
What's the? Yeah. I think I need to go over piecewise functions.
Yeah. Let me go to that.
Because I'm not remembering it.
Hey. Hey. You don't have to. You don't get this. It's not long.
Oh. Huh. Hey. Heck. Hold on. Oh, you got it. There you go.
Yeah, let's go over these functions real quick.
Nothing like Star Wars right there.
Yeah. Hello? Yeah, I got him. Oh, sorry. He's just playing. We're having a group math meeting at the house right now, so. You're good. You're good. You're good. I'll see ya. Yeah. Bye. Bye.
I can.
By now, we're used to seeing these functions defined like just y. square root of x. Or now, find by like this.
We're allowed to use notes.
Boy,
Your textbook.
I'm gonna
notes,
destroy you.
Yeah. Beckett. Sure.
Yeah, I'm finding it in the book. Oh, I see. Size functions are weird. Y equals x minus 2 for x.
Yeah, I guess I'll let you chew on it.
Okay.
Yeah.
Y equals. Where did my quiz go?
Yeah.
It's gonna do like the y equals x something for every x that's greater than 2 or greater than this.
I don't know if you read that.
Right. Graph equals function in calculus. Confused. so confused right now.
So it's like greater than or equal to sort of deal.
Yeah. Okay. X equals 0. X. Eric.
So if x is less than or equal to 0, the function is x plus 1. If x is greater than or equal to 0, the function is that's
It's like right there. Ah. So like a straight line. F of x equals 1. Y equals 1 for x less than 2. So when x is 2, not equal to 2, so it's like it's an open circle, it's not a circle. Y equals 1 for every x is less than 2.
So it's not like one equation.
Yeah, there's multiple equations.
Okay.
And you got like that one. So there's 2 equations here. Y equals x squared minus 4. Yeah. We got y equals x minus 2 for x is greater than
That'd be the
2.
Okay, so then from the negative or from like the infinity side to the 0.01.
Is there a point on negative 1, 0? Change all right there? Look like it, but. Let's take a shot.
So would this work for the first line? From negative infinity to 0, 1?
Yeah.
The x plus 1. Because if x is negative 1, plus 1 is 0. So negative 1, 0. If x is 0, y is 1. And that would be for x less than or equal to 0. Right?
My mind's getting destroyed right now.
Because if x is more than 0, then it's a different equation. But if it's less, like one of the points is negative 1.
You're right. Putting in those points into that particular equation. So the first one we have y equals x plus 4. And so if we put a negative 2 and plus 1, that'd be negative 1, which is straight. Okay, so then
So then the other equation is
And x.
the
Okay.
slope would be -2 minus 1 over 1 minus 0.
So what's the equation for -1, 0 between -1, 0 and 0, 1?
No, that's to help us get the slope and to get that point so that we can get the equation. Because in every equation on these graphs, you have like the slope and then you have like the y-intercept.
Mm-hmm.
And so he basically found the slope and then also the y-intercept, which is +1.
Okay.
So the equation for the first one is just x plus 1.
Yes,
Okay.
because the slope is just 1. So we're
Okay.
taking the point -1 to 0 and going to 0 and 1. That's up 1. So it's just 1 because it's 1 over 1.
And then do we write like the x less than or equal to
So
0?
the x is less than 0 for that, at least that equation. And then
I think the next one is -3x plus 1. Might be wrong. Because the slope would be -2 minus 1 over 1 minus 0, which is -3 over 1.
Mm-hmm.
So it'd be -3x, and then the y-intercept is 1.
okay,
And if you check it, if you do 1 for x, then that's -3 plus 1 is -2. Or if you do 0 for x, then 0 plus 1 is 1. So.
And so on that one, so it's like for x,
x is greater than 0, but
less than 1.
Third one.
0,
Greater than 0 but less than 1.
less than 1, yeah.
Because we're just going from that point to that point. And so then this next one will be
Is it less than or equal or is it just less than?
It looks like it'd probably be equal to because it doesn't have it, so they're filled in points.
Yeah.
Okay.
Less than or equal to.
And the next one would just be.
and then switch first, and then let's see his thing. Let me check.
X.
So the next one, tell me if I'm right for this.
You should. What did you get?
I got 4x minus 10.
Minus what? Minus 10.
How'd you get -10?
So considering that the slope is 4,
Okay.
what I did was I put in 3 for x, and then I got 12. But I know I would get an output of 2. So then if it's between 12 and 10, or 12 and 2 is 10. So then it'll be minus 10.
But the slope was 4?
It's a slope of 4.
Maybe 2.
No, just kidding, 2.
So the slope was 2.
Yeah.
I don't remember the formula to find the y-intercept, but just from looking at it, it would probably be -4.
Yeah.
So I got 2x minus 4.
After correcting myself, well, after you guys corrected me. Okay, so then x is greater than 1, but less than 3,
Yes.
and less than or equal to. Okay.
Okay.
So then I just put all that information just like right here. Just so like one equation.
Yeah.
Okay.
So we have y equals x plus 1 for x less than or equal to 0. Y equals negative 3x plus 1 for x greater than or equal to 0 and less than or equal to 1. And then 2x minus 4 for x greater than or equal to 1 and less than or equal to 3. Right?
Yeah.
Cool.
We gotta make sure not putting y equals since f of x equals.
Right.
Yeah.
Oh shoot.
Unforgivable.
Oh, that was a party.
And then the number 2, I don't know.
Okay. So for the following equation, identify all transformations. State the domain and range, determine which function and family it belongs to, discuss symmetry, if it's odd or even. State where the function is increasing and decreasing, and graph the function. Holy smokes.
That's fantastic.
So,
A negative 5, we can just put that at the end. That's your k. That's your y.
Do you know if it's taken?
He hasn't. Put it down.
so we can
You
go
can go
like
like f of x equals negative 2 x minus 3 cubed minus 5.
So your
A negative 2.
Isn't the minus 5, isn't the 5 minusing everything else for the negative 5?
I mean, it's not that like we're subtracting -5 from the whole thing. The negative is part of the 5. So it's -5 is the number. Does that
Oh,
make
we're just
sense?
setting that off to the
We're
side.
setting that
Yeah.
off
Oh,
And about
okay.
in
on the
the
other side so
proper
that it
form.
matches like our little formula that we have.
Oh, okay.
So hk is 3 negative 5.
Wait, h is -3 and k is -5.
It'd just be 3 because the equation
Okay.
for it is
Tissue.
So we got. I don't know how the a thing works. I know on there it just kind of expands it.
Okay, so
But
right. So the smaller the number, the bigger it is. So the bigger number, the smaller it is. So if this were a parabola, the -2, it would be closer to the y-axis on both sides.
Okay.
And if it was, in this case, since we're dealing with cube, we're doing like double thing. So being like more like this, it's more like straight up and down.
Okay.
What's the formula you guys are using? The HK.
So
if you look at the that function transformation widget
that
I
has
used earlier.
So
So
A
a is -2,
and
and
then
then
H
would be 3,
K
k is -5. So hk is kind of the
spot
spot
where
where it changes. It's the
Okay.
center of it. The center point.
And so identify all transformations.
So we go. Isn't that just saying like we go over 3,
Yeah.
down 5,
Yeah.
and then
And then
however that stupid a thing works.
shrink. shrink to shrink twice as much. Is that how we would say
I'm
it?
gonna look at it on here on this widget.
Are we allowed to use that in the corner?
It's part of our
Nope.
notes.
Three. Shift to -0. But actually, 2, right?
-5. Shift to the right 3. And
The other way
lower
around.
down. Oh, so negative flips it.
What?
When you go into negative on A,
Oh.
rather than going up this way, it flips it.
But also,
Going down
like,
that way.
so yeah, negative also flips it, but
Yeah,
also
and it
just
shrinks
numbers
it
it.
down.
Shift 3 up, no, down 5, and the reflection, or I shouldn't say reflection. I don't know.
If A equaled 0, it'd be a straight line.
Yes.
So it would be 2.
Kind
Kind of like the slope.
Yeah.
It's the
It's the slope of it.
intersects
Intersects
it.
it. Explain that. Okay. And that's it.
Okay, so that's part A. Part B. State the domain and range. So the domain would be like negative infinity, right?
It's just infinity.
Just infinity.
Yeah. And the red one to negative infinity.
Infinity to infinity.
I guess it is to infinity.
What?
Because it's negative.
So
So
it's
the
negative
negative
infinity
infinity
to
is
infinity?
going on, and then also on opposite goes
Right.
up. Then
Oh, so shouldn't it be domain is all your little x's, right?
Yeah,
Right.
so you could put any of them in there.
Infinity to negative infinity? Or is it just negative infinity to infinity?
I think it always starts at the bottom and goes to the top. I don't know.
Your range is all possible outputs, all possible inputs, so it's all talking about the x's.
Yeah.
So we're going from, so this is going from right to left. It's negative infinity, or infinity to negative infinity.
Well, if we're, I mean, yes, but also because of the negative here and how small it is, like the x can only like go out so far. Does that make sense? So like, instead of like going more this way, we're going more up and down. So the numbers are, there are some numbers that won't be touched because we're dealing with little. So it's only like a certain part of the graph, but not all of it. But the range would be infinity to infinity because it's just going upwards and down, and it's including all of the numbers because you can go on and on and on, up and down. I'm just imagining that in the graph. Does that make sense?
Kind of, I think. Because, so inputs, the way it goes, if you keep going, it's going to keep going. It's going to keep that radical diagonal. So you can't hit it every number. You look at it and
Yeah.
expand it forever.
Yeah.
And so I think the domain range is all real numbers. Yeah.
Okay.
Unless I'm wrong.
We'll see. I think that's right.
I'm just wondering if it's if it matters which way the graph's going. Should we just go negative infinity to infinity, or is it infinity to negative infinity?
So the domain.
Because it's
That's
going
true.
from left to right down.
If that even matters.
I don't
I'm
know.
not talking about how it should.
I think it would still be negative infinity to infinity just because of the values.
Yeah.
That's how it's ordered. So I hope so.
Tell me which function
Cubic.
Cubic.
Yeah.
Discuss symmetry, odd and even.
It's neither.
State where the function is increasing or decreasing.
Okay, so that's what we're talking about. So it's increasing from negative infinity to what is that? To -5, decreasing from infinity.
Decreasing.
And down this way. So it's just decreasing all the time.
Yeah. Yeah, because if this was a parabola, then we'd have to describe like, okay, so it's increasing from like point, I don't know, wherever 0 to like on, but then it's like decreasing on the other side, you know.
That's true. That's true.
But I think this one is always decreasing.
Always decreasing.
And those are closed brackets, right? With the box brackets.
It should be the open ones if they're infinity.
Okay. And now I have to graph. Oh.
I'm finishing this right on time because I gotta get to the school in like 15 minutes. And then study chemistry all the way there.
Okay, so can you give me some points?
Yeah, so your center is 3, -5.
My center is 3, -5.
And then so if you go over 1 up 2, that's where it's going to kind of cross. You keep going up.
So
That's the slope of it.
over 1 and then up 2.
I guess back 1 and up 2. You go over 1 and down 2.
Also the other way. Okay.
Starting at 3.
3, -5 is where the center is at.
Oh, really? Okay.
Yeah, that's kind of the HK, how that's set up. So you got x minus like 3 in that parentheses. 3 is h, because of how the equation is set up. It's always x minus x, whatever number. It's not negative 3, it's just 3. And then the last number is k, which is the y. -2. Negative flips it. and that's the slope.
So, like that.
Yep. Exactly.
Okay.
Cool. If you want to take the paper and scan or whatever, you can email it to me. That way I can send in the link and that same time. I think you send them at the same time, don't you?
What's that?
We submit the link with the group, right? Okay. So yeah, just email it to me, and I'll submit this link.
Will do.